Okay, we are going to work on homework 3. Question number 1. The measure of center that is value that is the value that occurs with greatest frequency is the, let's understand. So I'm going to, hold on, let me move here. I'm going to explain to you what that means. Let's say we have numbers 5, 9, 11. Those are data. Let's assume those are data, okay? 15, 1, 2, 3, 4, 5, 16, and 18. For easiness, I put them in arranging order because data can be given messy, so you have to arrange in ascending order to find the central tendency measurement. So whatever I'm going to explain, it's directly related to the question because the definition of mode that is gonna be the answer of your question, and I'll go over one more time. It's a part of this central tendency the measurement. So what are three central tendency measurement? That's a mean, that's a the median, and that's a mode. Mean, it's nothing else but average. To find the mean, all you are doing is arithmetical mean. So 5 plus 9 plus 11 plus 13 plus whatever you have there plus 18, everything. Okay? Let me see. Okay. And plus 18. That means 15, 16, you add them up and divide by how many we have total here. 1, 2, 3, 4, 5, 6, 7, 7, and we divide by 7. So whatever result you get, that's going to be your mean. Okay? Now, median. Median is we are taking the value of central position. Now, we have 7 elements, so 1, 2, 3, the fourth element, this one, 1, 2, 3, 13 is going to be your mean. You take the central position. Look, 3 from the left side, 3 from the right side. That's a median. So it's going to be 13. Now, what if I will have, instead of the 7 elements, I have even amount of elements. Let's say I have here 20. Let me add with different color so we can see that this is just an addition. Okay, I added 20. Then how we gonna figure out the median in that case? So since we have 4 and 4, it's altogether 8 elements, then we are going to take let me write down 5, 9, 11, 13, 15, 16, 18, 20. And keep in mind, it's crucially important to find median. You have to arrange numbers in ascending order. So since when we had odd amount of elements, it's very easy. We take central position. But what if we have even? I'm taking middle 2 positions. 13 and 15. Look, 1, 2, 3, 1, 2, 3. And with middle position, what I'm going to do is get average, meaning mean of these two. 13 plus 15 divided by 2, which is going to be 14. In this case, median is going to be 14. Okay? So, real quick, when you have even amount of elements, you take middle 2, and find the average between these two, and you are getting median. One second. Okay. But if you have odd amount, then you just take the middle. And lastly is mode. Mode identify which numbers have the highest frequency. Let's say in this case we don't have any frequency, right? Here mode is going to be no mode in this case. But now I'm going to give you an example of the case where we have different numbers and we have mode there. For example, 2, 4, 3, 2, 3, 6, 4, 5, 7. So what do we have? We have twice 2, right? And then we have twice 3, right? And the highest frequency, what do we have? Oh, we have all equal. Yeah, I don't like it. Let me to make it your example is better. I put one more 4. And we have how many? 1, 2, 3 times 4. So the mode here is going to be 4 because 4 has the highest frequency. Okay? Now let's assume, and if I wouldn't put 4, then you will have twice 4, you will have twice 2, and you will have twice 3. So since they are equal, their frequency, so your mode would be 2, 3, and 4. Are we clear? Okay. So in this case, since once we got familiar, what is going to be the answer in this case? The measure of central, that the value, that is the value that occur with the greatest frequency. And the answer of it is going to be, obviously, mode. Okay? All right. Doing good. Nice work. Moving to next question. What is the following is always true? Let's see. The mean and median should be used. Oh, one very important thing. If the data can be actually distributed bell-shaped, meaning symmetric, they can be distributed skewed to the right, and it can be distributed skewed to the left based on numbers. When data are symmetric, then we have mean, mode. Use your imagination. It's supposed to be symmetric. Okay, mean, mode, and median, they overlap each other in the same position. Okay, so when data are skewed, they greatly affect mean, because to find out mean, we are adding every single number, correct? And let's say if I have 2, 3, 4, and then I have 200. So this 200 is going to pull the mean higher, correct? Or if I have 50, 60, 70, and all of a sudden I have 2, I'm bringing a big difference, so make it clear. Then it's that 2 is going to pull down the mean, correct? So when it's we have data skewed to the left, then mean is going to be dragged to the left, but the median will not be affected by any data because we are taking position, not the value. Okay? And it's the same thing here. Mean, because it's skewed to the right, the mean going to be skewed to the right, but the median is going to stay solid where it's supposed to be by position. Okay? All right. So, going back to our question. So what the following is always true. The mean and median should be used to identify the shape of distribution. That's which is also, I would say, is true. Yes, if mean is less than median, then you have skewed to the left, right? Look here. If the mean is less than median, then we have skewed to the left. If mean is greater than median, then we have skewed to the right. Let's read other the answers. Maybe we can find the best answer. So question B, in symmetric and bell-shaped distribution, the mean, median, and mode are the same. Now, this is 100% true. I would say this is going to be the answer, but let me read the rest. The skewed data, for skewed data, the mode is further out in the longer tail. That's baloney. That's not the case, because mode doesn't necessarily have to be in the tail. And data skewed to the right have a longer left tail that no, then right tail, no. So this is 100% information. In the symmetric, this the mean, median also should be used to identify shape of distribution. But we have also, what if we have the same, if we have uniform distribution? Then that case is not going to work. So the best is going to be answer B, that when we have symmetric bell-shaped distribution, then mean, median, all three centralized measurement are going to be the same, and they're going to point symmetric and bell-shaped. Moving to next question. Question number 3, determine whether the approximate shape of distribution in the histogram, symmetric, uniform, skewed left, skewed right, or none of these. Okay, histogram, let me explain to you. This is in front of you is histogram. It's like bar graph, a graph that doesn't have breaks between bars. Okay, if bar chart looks like this, the histogram doesn't have this space. It has, histogram doesn't have space. So they share the wall between these two columns, okay? It can be any the shape, but it's gonna be, this is how it looks histogram. Histogram is used for large samples, okay? So let me explain the shape of the histogram that can be uniform. Uniform is the way it's given, meaning same height, same frequency, no difference, okay? And so on. So this is uniform. Then symmetric. Symmetric, we already know what it is. It goes symmetric. Okay. So this is approximately symmetric. Skewed to the left. Skewed to the left, and accordingly skewed to the right. Okay, skewed to the right. And none of them, well, it's going to be some messy, let's say. For example, see, this is none of them. All right, so back to our answer. So in this case, we have obviously uniform. Next one. Oh, how lucky we are. This one also uniform. Okay, consider frequency distribution. Frequency distribution meaning this vertical line is a frequency, okay, of scores on a 100-point test where the students scored much lower than the majority of students. Match this distribution with one of the graph shows below. Okay, let's see which one is matching to what. frequency of scores on 100-point test where a few students scored much lower than majority. Okay. Few students. So which one it's gonna be? They scored much lower. Much lower, meaning the histogram is gonna be skewed to the left, right? If it would say few students were scored much higher, then it's gonna be skewed to the right, correct? So which one is we have skewed to the left? C, correct? Skewed to the smaller number. So here it's gonna be C. Where is my C? Here it is. Fantastic. Question number 6. Well, we need to find the mean here. All you're gonna do, add them up, the numbers. So let me add them up. Whoever knows how to work with Excel can use Excel. Whoever doesn't know, you can use basic calculator. So I'm adding 1273 plus 816 plus 1226 plus 1124 plus 1277 plus 1153 plus 1369. So how many numbers we have? 1, 2, 3, 4, 5, 6, 7. So this summation I'm dividing by 7, and I'm getting 1176. So we can round to 1 decimal place. So it's gonna be, let me see, 1176 point, well, 0.8. Okay, let me see. 76. Sometimes it's possible. Let me put 7, round till 7. Sometimes they ask to round, but they themselves don't round. Okay. Then maybe math is incorrect. Let me do it again. 1273 plus 816 plus 1226 plus 1124 plus 1277 plus 1153 plus 1369. Okay, and 1, 2, 3, 4, 5, 6, 7 dividing by 7. Let me see this time if I get, well, I got same number. Let me see, 1176. Since I have after 7, 6, I have coming 8, 5. Usually I would put, instead of 0.8, I would put 9 because it's following 1 additional decimal. But I don't know if here Pearson accepted. Well, it's accepted. So, okay, we are good. What is next? Does the mean represent the center data? You know how we're gonna figure out? What did we say? Remember what I actually what I explained? I said mean always gonna represent the center, right? But it can be skewed, correct? So, in let me see, mean does not represent, that is not right. Mean does not represent, I don't even want to read continuation. The mean does not represent. Also, I'm not going to read, there is no mean word count. This is also nonsense because we have numbers, we can count, and we just count it. Therefore, I'm choosing the mean represent the center. Okay, in the next question, find the median. Okay, to find the median, we have 7 elements, right? So, which means the fourth element, which is, it's not, okay, this is not arranged in ascending order. So, I need to arrange. So, the smallest number, I'm going to find the fourth number in ascending order. The smallest one is 1124. This is 1. Next is going to be 1153. This is second number. Third one, oh no, I'm sorry, 816. So 816 is first one, 1124 second one, 1153 third one, and what is going to be the fourth one? 1226. Because there are 7 elements, the fourth one is going to be our median. So 1226. 6. Bingo. And if it would ask for mode, in this case, we don't have any mode because we don't have any repetition of these numbers, right? Okay. And the last question, does the median represent the center of data? The median represents center. Where do we have? There is no median, does not, which cannot be. Yes, median represent the center. That's the best answer. Okay, moving to question number 7. Oh, what we didn't check here. The mode of the word count. Okay. This is the answer. There is no mode. We don't have repetition, so there is no mode. Okay. Next question, number 7. How many questions we have there? Question D. Okay, let me see question D, what it says. The mode represent the center. Correct. Correct. Mode, median, and mean. They represent the central tendency to the data values and determine if the represent is typical central. What? Does the mode represent the center of the data? Maybe they are asking for this case. Okay. In this case, I would say there is no mode. But in general, yes, I went to as a general. For this case, otherwise, there is no mode. Okay. Fantastic. Question number 7. Finally, we move to question number 7. So what do we have? We have table, type of lenses, and frequency. Right? So, it's asking, find the mean. Well, we have frequency. When you have frequency, you cannot calculate the mean. Right? There is no way to calculate the mean. So here it's going to be the mean cannot be calculated because the data are the nominal level of measurement. Yes, it's representing type of levels. It's a contact, eyeglasses. You can find average of eyeglasses or contacts. And it's frequency, how many of contacts, how many eyeglasses. So there is no mean. Checking. Nice work. Moving to next question. Does the mean represent the center of the data? Okay, well, we already answered, right? The mean does not represent center of the data because the data set does not have a mean. Because we have frequencies, we don't have the values of data, right? Okay. Checking. Next question. Find the median. Well, again, median cannot be calculated because data are on nominal level. Remember, right, what means nominal level? We have labels, something that you can't count it. Okay? You can't find the average between contact eyeglasses and so forth. And those are frequency, how many of each of them. So in entire this set of these lenses, type of lenses, you can find a mean or median. Okay. And lastly, does median represent the center of the data? I would say yes, because if I understand correct, it's a generally it's asking. Yes. Well, let's see. No. Okay. Well, in this case, it's going to be the same. Let's read. The median does not represent, cannot, because it is larger number. The that's not, we don't have any small number or large number. The median does not represent the center because it is not a data value. That's what it be. Oh, that's one thing. The other one, this is the best one. The data set does not have median. Fantastic. And lastly, choose the correct mode of the data. So to find the mode is which one with the highest frequency, right? Which one is highest frequency? That's contact and eyeglasses, correct? 610. This one. Okay. Again something? Oh my God. It's like there is no limit. Does the mode represent typical or central data entry? Now this one, it's a general question. Yes. The mode represents typical data entry. All right. Finally, hallelujah, we are moving to question number 8. So looking at the graph here, we have histogram. So we need to find the range. What is the range in a data set? Range is when you take maximum minus minimum. That is range. So let's look here. Women age at the first childbirth. So highest is 34, lowest is 24. So it's going to be 10, right? Okay. Number 9. We need to find the range here also. So if I zoom, so the highest is here, how much? 95. Lowest is here, 70, 71, 72, which means 95 minus 72, and we are getting 23. What we did wrong? Here we have high, 100. Oh, here it is 100. I didn't notice. Okay. 100 minus 72. And we get 28. Okay. We fix it. Okay, beautiful. Moving to next question. Here we arrive to box plot. Box plot, it's an analysis tool when we trying to find out if we have skewed data. Another way to identify, you can identify data are skewed or not by a histogram. The same thing you can do analysis tool, it's a box plot. This is what we call box and whisker plot. These endings, that is at 935 and 2088, those are we call possible outliers, whiskers, and in the middle we call interquartile, the box, the length of the box that starts at 1202 and ends with 1095. We call interquartile, which is its length of the box where data are located. This color means that's where data are located. 1541, that is our mean median, okay? Now, what we're gonna do, we need to find our, let me see, minimum. So, our minimum is going to be 936. Let me write down. What is wrong? Is it not precisely 935? Okay. Okay. Q1, it's a quartile, first quartile. Let me see, I'll show you what is first quartile. This 1202 is our first quartile. What does that mean, first quartile? First quartile shows the the first lowest 25% of data from, let's say, 935 to 1202. That's first 25% of entire data. Okay, so first quartile 1202. And then second quartile, which we call also median, is 1541. And third quartile is 1915. Okay? So let's place 1202, that's the first quartile. Second quartile, 1541. Third quartile is 1915. And the maximum is going to be 2088. Now, here is the thing. Before I move, okay, we haven't checked it yet, right? Or did we? Oh yeah, it checked already. Let me explain here real quick. Based on box plot, see, when you have some whisker this long, let's say it ends with 20, and here is the 2, for example. So this 2 is possible outlier, okay? So the other thing I would like to mention, if its median comes here, that means data skewed to the right, okay? If the median comes this way, that means data skewed to the left, all right? Okay, and that's how you can analyze and figure out. If median located right in the middle, then you have the box plot, you have the bell-shaped inside. But here you have outlier. Median is not skewed. Median is not skewed, but here possibly you have, usually it's not going to happen like that. If you have here outlier, so it's going to be some stretch of mean. Okay? All right. Next question. Number 11. Okay, what do we have here? Beautiful symmetric box plot. Excellent. Moving to next one. I guess we already, okay, how to find out at the quarter one, at the Q1, Q2, Q3. Let me explain to you. I'm not going to sit and calculate this long, but I'm going to explain to you. So how many elements we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So instead of 20, I'll take some easy numbers so I can explain to you, okay? And you can do the rest. Or I have to transfer to Excel or StatCrunch, and I'm not going to do that. You can patiently add everything. So since we have even number, I'm going to get even number, so it would be the same. First thing, don't forget, you have to arrange in ascending order. So I just take the data that are already in ascending order. 1, 4, 6, 9, 11, 12, 1, 2, 3, 4, 5, 6. Let's take 15 and 18, let's say. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we need to find Q1, Q2, Q3. We always start with Q2 because it's a median. So Q2, since 1, 2, 3, 4, 5, 6, 7, 8. So the fourth one, 1, 2, 3, the fourth one, it's going to be our median. Now, next, to find Q1, 1, 2, 3, hold on. Even number. Sorry. Even number. Why I took only fourth one? We have even numbers, so I'm going to add middle 2, 9 and 11. 9 plus 11 is 20. 20 divided by 2 is 10. So Q2 is going to be 10. Now we have left what? We have this 3 here, and we have this 3 here. This is going to be Q1. So, but that Q1 is going to be median for the low level numbers, and Q3 is going to be median for the higher level of numbers. So Q1 is going to be 4, Q3 is going to be 15. Okay, so that's how you're going to fill out. At this point, I'm going to just open this answer for this one. So once you add, you can check if you got it right or wrong. So this is what you're going to get. 2, 5, and 7. So again, you have to arrange in ascending order. First, you need to find Q2, and then you go back Q1, and then Q3. Now, we need to find out which one is matching up this box plot. Although it's answer already chosen for us, but I will show how we're going to do. So Q1 is going to be 2. I'm looking, my Q1 is already 3, so it's not going to work. Looking B, Q1 is 1, right? Q1 here is 1. And we have C. See, Q3 is the first case. We have Q1 as 2, which is that matching so far. Next, Q2, it's a median. It has to be 5. Let's check. Indeed, it's 5. And the Q3, it goes as a 7, which is the case. It's C. All right. Moving to question number 13. And I'm taking this off because I don't want all answers show for us. Okay, here what we have, we practically have this rate, pulse rate, and frequency. So we need to see which histogram is matching. This is how I'm going to find out. Look, I have the lowest frequency is 100, 109, and the highest frequency is 58. So I'm going to see which histogram has the highest frequency, 58, and the lowest 2 at a high pulse rate. Let's see, and 58 supposed to be for the pulse rate 6069. Let me see. Okay, this A can work, C can work, B no is not gonna work, and D also is not gonna work because it goes between 80 and 90. So it's gonna be between A and B. Now 100 and 100 what? 100, 109 has to be 2 frequency, right? 100, 109. This one looks like it's coming to 100, 109. Let me check the other one also. Yeah, the other one, 100, 109 is coming over 9, or how much? 7, 9. Yeah, it's not, which means it's going to be A. Okay? Nice work. See how I figured out? So that's the way you're going to figure out. So what else do we have here? We have another question here. Let me move this up. So, do the pulse of male appear to have a normal distribution? Since the answer is A, so normal distribution. What is the answer? Since the histogram has, what is our histogram? Is it bell-shaped? Well, we have also the data going down to the left and data going down to the right. Approximately, we can say it's bell-shaped. We can't say it's skewed to the right because on the left side also it's going down. And we can't say skewed to the left because on the right side also. So we're going to say approximately, or has here what? Roughly symmetric in double quotes. Yeah. Why we don't take the last one? Has a roughly symmetric shape with bars with approximately equal height. First of all, it's not equal height, and the other one, we put bell-shaped. I like this better in double quotes because it's not. It's approximately. You have to kind of adjust to get true bell-shaped. Okay, so since the histogram has the rough symmetric bell shape, the pulse rate of male, let's say what we have, don't appear to have a distribution that is approximately normal. Well, then I would say appear to have a distribution of that is approximately normal. Checking the answer. Okay. Number 14. We have still some question I didn't notice there. Okay. Are there outliers? We're looking at our A. Do we have outliers? It goes, there is no some drastic jump to small number or drastic jump to big number, right? It goes gradually, 60, 50, 40, and then 60, 70, 80, 90, 10. So there is no outlier, I would say. If I would throw there, let's say, after 110, I would throw there 200, that would be outlier. So where do we have? No, there is no outlier present. Okay, finally we are moving to 14. So we're gonna build a stem and leaf. What is stem and leaf? That's a graph that we use, just like histogram we use for large samples. We use stem and leaf for small samples. Let's assume we have numbers 53, 64, 29, 45, 46, 55, what else? 45, 48, 55, okay, 57, okay. So our stems are going to be the first numbers. So what stems do we have? 2, 4, and 5, right? So stem, well, I'm writing this way, 2. So 3 is missing. I put here 3, and there was no leaves. I will explain to you. 2, 3, 4, 5, 6. Your stem has to be in sequence. They can't miss any data. But let's say 2 has leaf 29. Has leaf 29. There we go. And that's how you read 29. And then 3 has a leaf. We don't have any leaf for 3, so we leave space. Next, moving to 4. 4 has 5, 5, 6. In order again, 5, 5, 6. 5 has 53, 55, 57, so it's going to be 3. And then it's going to be 5, and then it's going to be 7. See, I'm putting in ascending order. And 6, it's going to be only 64. And that is going to be your stem and leaf. Now, to read backwards, you're going to read 45, 45, 46, 53, 55, 57, okay? Now, how about 3? If you don't have any number here, that means 3 is missing. But if we would have, let's say, how do you know if we have 30 or if 30 is missing? If I would have 30, I would have here leaf with number 0. Then I would have 30. But because I don't have it, I leave space, and you know that there is a gap. Okay? And that's how you're gonna fill out. So let me, I'm not going to write down all this, but I just open it. So what do we have here? We have 3, 0, 8, which means we have 3, 0, and when we 3, 8. Let's see, I have 3, 0, I'm looking at it, fourth number, and 3, 8 is the third from the backwards, 38. Now with 4, I have 4 numbers with stem 4, because I have 43, 46, 48, 49, right? So 43, here it is, I found, that's 1, 2, 3, 4, fifth one, 43, and then 46, 48, 49, I found it. Okay, so all you have to do is just look, the stems, you are going to pull out the stems. The smallest stems start with 3, and then that goes all the way to 7, highest, no, 99. So you have to put all numbers from 3 to 9, see, just like we did. And then start looking which one has stem 4. We have 4 numbers, 43, 46, 48, 49. For 5, we have 2 numbers, 51, 54, and you put leaves, 51, 54. Okay? Now, so let me take this off. We can do it between. Okay, let's see what is the question. How are data sorted in stem plot. The data are arranged in order from lowest to highest. We already know ascending order, increasing order. That's the first leaf in the first stem. It's going to be the lowest one, right? It's going to be minimum. In this case, it's going to be 31. And the maximum is going to be 92, correct? 31 maximum is the highest, is going to be 92. I hope I explained well, but if anybody has hesitations or questions, I am one phone call or one text message away from you. Okay, moving to next one, number 15. Okay, number 15 is the same way, practically. So it's the smallest one is 6, 0. Here it is, 6, 0. And look how many 6 we have. 60 something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers with 60. Okay, and 3 numbers with 90. So I am looking here 90, 90, 90, 3 times 0, 0, 0. Okay, so which means the two values that are closest to the middle when the data are sorted in order. So which numbers is middle? Middle is going to be the 70 something, right? Because we have total how many numbers? 1, 2, 3, 4. I'm counting, they are our database. I'm counting only one line and then multiply by 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 24. So our two middle is going to be 12 and 13, right? So the lowest to highest, so what's it? Hold on. The two values that are closest to the middle when data are sorted. Okay, 12, 13, it's going to be counted as a median, right? Because we have 24, which means I'm going to take one number lower to 12. It's going to be 11th number, and next number higher than 13 is going to be 14th number. Now, how are we going to count 11th number? We have 60, we counted how many? 10, 61, 0, 2, 2, 4, 6, 6, 6, 6, 8, 8, 10 numbers. So it's going to be 70, 11 number. Number 11 going to 70. And after 14, so 70 is 11. Another 70 is going to be 12. 72 is going to be 13. So 14 is going to be 72. Okay? I hope I made it clear. All right? And you know where to find me, obviously. Number 16. Oh, that's it. We arrived. We are good. Okie dokie.